All right, hello math fans. Today we're going to be graphing linear inequalities in two variables. So we're going to be graphing, basically we're graphing inequalities in two variables. Well, we've already done graphing in one variable. Okay, if you remember, that's basically if I just had x is greater than 5, you'd make a number line. Well, now we're actually combining graphing inequalities with graphing just regular lines, one variable and two variable. All right, so let me just give you an example. If I ask you guys to graph y is equal to 2x plus 3, you would graph like normal. You would say up 1, 2, 3. That's your y-intercept, the 3 there. It's plus 3. And then you would say your slope is 2 over 1. So right here you'd go up 2 over 1. And just to make it a little more accurate, go down 2 into the left 1. And you make your graph. Okay? Now what we're going to do is same thing, but we're going to graph y is less than 2x plus 3. Now there are two differences between graphing equalities and inequalities. First of all, just like when we graph with one variable, if I graph x is greater than versus x is greater than or equal to, it's an open dot versus a closed dot or a filled dot. Okay? Well, this is the deal. If it's less than symbol or greater than symbol, it is a dotted or dashed line. Okay? And if it is less than or equal to or greater than or equal to, it's a solid line. So that is the first difference. Be very careful, make sure you do that, because if you don't do that, you're going to lose 1 point off of there. So you have to make sure you have the, you look at which inequality you're using. So another difference with this type of problem is the shading. So if I would basically, this line from the original problem represents a solution to the graph. So if I pick a point of, this point right here, which is 1, 5. That is a solution to this equation because it's 5 is equal to 2 times 1 plus 3. So 5 equals 5. That's one of the solutions. But I also can pick values. Now for the inequality, it's y is less than 2x plus 3. So if I have a value, again I pick a value of 1 and I plug it in here, I get 2 times 1 is 2 plus 3 is 5. I can have 4 is also an answer because 4 is less than 5. I can pick 3, 2, 1, 0. I can pick any number less than 5. I can pick 4.99999. Anything is less than 5, I can pick for that. Okay? So you represent more solutions by actually shading. So let's actually do this problem. Instead of y equals 2x plus 3, we're going to do y is less than 2x plus 3. So if I graph this, you graph it exactly the same as you did before. You have 3, and then I go up 2 over 1, down 2 over 1. And then remember, it's a dotted line. And with this inequality, it's less than, so you really shade below the line. So you shade below the line, which is basically right there. And that's your answer to that problem. Okay? So that's what the difference is. You're shading and you're looking for dotted lines versus solid lines. So let's just try another one real quickly here. Y is greater than or equal to negative 2/3 x minus 1. So we go down negative 1, down 2 over 1, 2, 3. It's a solid line. It's greater than, so if it's greater, you shade above the line. Okay, very simple. So again, I have my solid line, and I just shade above the line. Now I'm shading here, but technically it just keeps, it goes on. It's all over. Anything above that line, because that line goes on for infinity, and you just shade above the line all over. Okay, it's pretty simple. All right, so what makes it a little more challenging? Well, if I have a problem like this. 2x minus 3y is greater than or equal to 12. Well, what we're going to do is we're going to solve for y. So you have to remember, back in the day, we learned how to solve for y. So you're going to combine solving for y, but you're also going to combine inequalities. So if there's something where you're dividing by or multiplying by a negative, make sure you switch around the inequality. This entire chapter is based on that idea of you divide or multiply by a negative, you switch around the inequality. So I'm going to subtract 2x from both sides. And get negative 3y is greater than or equal to negative 2x plus 12. Divide everything by negative 3. So y, you switch around the inequality. It's positive 2/3 x minus 4. So we graph it. Down 4 and up 2 and over 3. It's a solid line. It's now less than. So that means you shade below. Very simple. That's it. That's all you do. Okay, so let's do another one here. It looks a little more complicated, but if I have something like 5 is greater than 2x minus y. So you should know what to do with this problem. The first thing you want to do is you want to get the variable that you're solving for on the left-hand side. So I'm going to switch the entire problem around. It's 2x minus y. Now it's pointing to that, so better point to that again. 5. I've now made this a lot simpler because you don't want to solve for that y when it's on the wrong side. So I'm going to subtract 2x. I'm going to get negative y is less than negative 2x plus 5. Divide by negative 1. And remember, I divided by negative, so I switch to the inequality. I get 2x minus 5. So if I graph it, negative 5, turn that to be 2 over 1, so it's up 2 over 1. And we'll do a few more points, it's always nice. And don't forget, it's a dashed line. It's greater than, so you shade above the line. That's it. Now, you got to be a little careful because when you are shading, let's do a problem. I'm not even going to give you an equation. But sometimes when you're given a line and it's a really steep slope, sometimes people get a little confused on what's above and what's below. It's tilted just a little bit clockwise, a little twisted to the right, or tilted to the right. So if I wanted to shade below, this is below. because it's still a little bit below here, and this is above. Okay, so that's pretty straightforward. Okay, let's do some band problems. If I ask you guys to graph y is greater than 3, well, that's really easy. But you guys know a band problem. Remember, a y is an upside down h, so it's a horizontal line at 3. Don't forget, it's a dotted line. And this is really easy because it's greater than 3. That means I shade above the line. Pretty easy. If it's less than, you shade below it. That's really simple. Okay, the only one that's just a little more complicated, and it's not that big of a deal, is if I ask you guys to graph x is less than -2. So you're going to graph it first, and you're going to say, okay, remember it's a vertical line. Again, it's a dotted line. But I always said if it's less than, you shade below. If it's greater than, you shade above. What you need to realize is that there's no above and there's no below here. But think logically. If it's less than 2, this is negative, or less than -2, that means it's got to be like -3 or -4, -5. So you're basically shading to the left over here. Okay, it's not difficult, but you have to understand that. Okay, it's shading to the left, and if it's over here, then it would be greater than -2. You'd be shading to the right. Okay, just think logically what you have to do. All right, and so if I give you y minus 2 is less than -4. Well, and I ask you to graph that on a number, or on a xy axis. Same deal. You're going to add 2 to both sides. Y is less than -2. So there it is, -2. Dotted line. It's less than -2, so it's below. Okay. If I ask you guys to graph x, or 3 minus x is less than 4, you're going to subtract 3 from both sides. So -x is less than 1. Divide both sides by -1. X is, now you switch around the inequality, greater than -1. And then once again you graph it. Here's -1. It's a dotted line. And it's greater than that. So that means I'm going to shade where it's greater on the right hand side. Okay, that's it. It's pretty easy to graph linear equations or inequalities in 2 variables. Again, you graph it all the same, and you make sure you know how to solve for y, and you graph everything the same. And if you happen to divide by a negative, you flip around the inequality. Once you do that, then 2 different things. One is if it's a less than or greater than, then it's a dashed line or a dotted line, and if it's less than or equal to, or greater than or equal to, then it's a solid line, and then after that you shade. So you either shade above if it's greater than, and below if it's less than. Okay, that's it, algebra friends. Have a good day.